Muchísimas gracias, mi amigo. Okay, I'm at 48 responses. Come on, chop chop. Okay, time's up. Series. There are multiple good ways to define it that I've seen. Great, but not good enough. I want everyone to see this. I don't want you guys to fail. One good way to see it is if the wire connects directly with no junctions. If wire connects directly, two components are connected directly with no junctions. Another good way to say it is current has only one way to flow. Or let's see, where is another person said, when current has no choice but to go into the next component. Direct connection without junction. Only wire connecting between them with no junction. So let's apply that. I'm going to give you 3 examples of things that may or may not be series. Apologize for my resistors. You guys remember what the squiggle means? This squiggle, the enye? There's more circuit there. It's not just floating off into outer space. That component is connected to something. Okay. This, turn to your neighbor. Point to it. Oh, for God's sake, you can't do this without, let me name them so we can discuss. This is not Google. This is brief discussion. Test yourself. And your answer should agree with what you just wrote down, ding dang darn it, on the Google form. Look for series combinations here. In particular, I will emphasize for the test, you must be able to combine components in your head into a combination and then say, how does that combination connect to something? Then say, how does that combination connect to something? You do need to do that to calculate total resistance, to calculate what current flows where. That's on the test. But when I ask, and I will ask, is A in series, parallel, both, neither, to B, I will only ever ask about dose components at a time, 2 components at a time. Is A connected with B? If A is in series with B, which is parallel with D, B and D are in parallel, and B, A is series to that, you don't tell me about a combination. I'm specifically asking about 2 specific components. Ready, set, go. Give it a shot. Not Google form, talk to each other. Identify in your brain. One minute. Justify why. Not just what, but why. 1 minute. Series only. If there's a junction, there's no series. There could totally be junctions with parallel. No, series and parallel are not opposites. Yeah. Junctions don't break parallel, but junctions absolutely break series. Good. Sure. Okay, time's up. Oh my God, I want bed. And that's the answer to number 1. I hope you identified B, E, and D are in a series relationship with each other. Yeah. Now, please note, the answer to the question that I'm going to ask you, if this is the problem, is not to say that B, D, and E are all in series with each other. They are, but I will specifically ask you, is B in series with D? Is D in series with E? 1 resistor at a time. D is not in series with E? Really? What's this? There's no resistor between them. That's true. That's true. It's not the same wire. If it were the same wire, that would mean it's not in series. If this wire goes to a third place, that breaks series. So B and D are in series. D and E are in series. Oh, one more thing I just thought of yesterday class. A silly example. Series is monogamy. Series is monogamy. 1 connection. Breaking series as if there's either cheating or thruples or polyamory, whatever. If there are 3 at a point, that's not monogamous. Okay, muy, importante are A and B in series. No, why not? C stands for cheater. Exactly. C breaks AB series. Okay, now in this example, did you see IL? Please note, in initial diagrams drawing series, it is common to draw one component and the other component in a line. Geometry on a schematic diagram is meaningless. This diagram with these little funny symbols, the orientation and position of the components has absolutely nothing to do with electricity. Okay? It is supposed to be for clarity of communication between engineers or physicists analyzing stuff. So the fact that I and L are at right angles to each other has nothing to do with the fact that they are connected. They are connected at a point. And is there a third component connected here? No, 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 no. They're married. They're very married. Okay. G and H, are those series? Why? J. Are H and M in series? No, 2 reasons, J and K. They're not in series on the right because K. They're not in series on the left because, well, G, J, and L. H and M are about not as series as you can get. Are H and M in parallel? Check it, baby. Check it. Check it before you wreck it. Things are in parallel if they're connected directly on both sides. Are H and M connected on the right side? Directly connected. There is a wire path. Shoop-a-doop-a-doop-a-doop. Please note, junctions are where wires come together. A junction doesn't block it. It is the opposite of blocking electricity. A junction does not block a wire path because the junction is nothing but wire. So this is a path, a junction, no blocky. Okay, parallel, they're connected on the left and they're connected on the right. So let's trace through. On the other side, are these connected? Bonk! No. The damn J. Ugh. J got in the way. Okay, So H and M are not parallel. The schematic symbols orientation has no effect on series parallel rules. Now, that is still screwing with like half of the lab sections of my lab sections that I teach. It's still screwing with half of the students in each. Please, please turn to each other right now and explain to each other why IL are series, GH aren't. Explain to each other why HM aren't parallel. Oh, do you see any parallels in here? Any parallel? No, there are no parallels. No parallels here whatsoever. Yeah.
Say that the combination of I and L and G and J are in parallel.
So IL, and you'd have to combine all this for GJ because this is connected. Yes, but I want to emphasize, you would have to do that. You're doing a circuit analysis, find the total, but I'm never going to ask you combinations on this test. So yes, but for the sake of simplicity, I'm going to say that's not part of the test.
So you're saying that such kind of circuit problem won't be on the test?
I'm saying that to find the total resistance, yes, you will absolutely need to combine series with their greater parallel and that combination with the greater series and so on. But I am specifically testing on one idea. Can you identify are two components in series, are two components in parallel? The people who can't even do that are going to fail in the find their total resistance problem. But I want to check these things independently, so they're different questions. So when I ask, are these two components in series, I will ask, are I and G in series? Are I and G in series? Why not?
Because the things are blocking direct connection, such as J and L.
Oh, they're directly connected. F. That's parallel. That's parallel. They're connected at one end. They're not connected at the other. Breaks parallel.
Does it mean they are also in series?
Series and parallel are not either or.
Yeah.
They are not opposites. If you're in series, hell, maybe that's a question. If things are in series, can they be in parallel? The answer is yes. Here's a circuit where things are both series and parallel. It's the first circuit. The first circuit. No junctions. Top and bottom. Series and parallel.
The circuit is not series doesn't mean it has to be parallel.
Correct. Muy importante. Yes. You could be both. You could be neither. You could be one. You could be the other.
Value all for the circuit approach.
No. On Monday, maybe a simpler one. I will give you 4, I think, resistors and ask you to be able to combine them, and the numbers will be easy. But no, I don't want to do that now. There's still a little bit about magnetism. So wait, or ask on Monday. Okay. Series parallel. Series parallel. Can you identify them? Huge, huge, huge. Then be able to combine them to find total resistance. Trace that current that flows here, there, and everywhere. That's also huge. There was a third thing that I did for my 3 o'clock. Excuse me for just 1 second. I started off by doing an arithmetic survey. Oh, it's on the tip of my brain. Okay, I'm going to remember this. I'll probably remember this the second after I dismiss you. Oh, for God's sake. Okay. I wanted to do the same review for both, but screw it. What are we on? The people who are able to connect. Yeah, good. Hey, same number. Okay. Don't look at your notes. We did do these examples before. I wanted to see if you could still do them. Check them. Check them before you wreck them. Right hand rule. And if you can Google Form, do Google Form. Okie dokie pokey pony, as my father used to say. Rip. Let's do it together. Check your hands. Your hands should look like my hand. We're going to do it relative to this plane here. This is the into the board direction. This is the out of the board direction. Right and left, up and down, God willing, you know. Number B, whatever. Down. Hands go down, or fingers go down. Palms go facing left. Yep, my palm is left. Which way is my thumb pointing? Shoot, in. Down, cross, left is in. Yeah, someone got something? Yeah. Next one, up. Fingers go up. Now don't change, your fingers go up and use your right hand. Use your right hand. To avoid turning your fingers and breaking that first vector, just think, you can only rotate your hand. Don't do this ever again. You're frozen. These joints are frozen. Now, up, cross in. I've got up. Which way is in? Slap the board. Up, cross in is which way? Left. Which way is my thumb pointing? Up, cross in is left. Right, cross in. Point right. Right side of the board. Cross in. Slap the board. Up. Left, cross down. Point left. Face down. Which way is this? out of the board. Down cross right, shrink, shrink. Wait, that's left, shrink. Down cross right is? Yeah. Ooh, dance. Up cross out, up, out, right. Because your left hand and right hand are mirror images of each other. The relationship between thumb and palm is flipped. If I put my thumb pointing towards me, put my thumb pointing towards me, I put my fingers facing up, these palms face opposite ways, right? This palm faces left, right, this palm faces right, left. Yeah, it would flip it. It would flip your answers. Okay. There is one deet. There is one deet that I did not emphasize. Did I tell you what you do if you get a negative charge? I have just taught you how to V cross B. I taught you how to cross any two directed quantities. We'll actually see this later. MCAT students, torque is also a cross in there, if you encountered that. So I have taught you how to V cross B, to multiply two vectors together in this way. What happens if I calculate V cross B as up, but Q is a minus number? Q is negative something. What's negative up? Down. Yeah. What happens if V cross B is right and Q is negative? Left. What happens if V cross B is east and Q is positive? East. East. If Q is a positive number, just do V cross B. If Q is a negative number, still do V cross B, but flip your final answer. I strongly suggest that you do it this way. I really have some data to suggest that you will make fewer mistakes if you do it one step at a time. First, calculate V cross B, and then do I flip it or not? Electrons and protons are pushed opposite directions. There are the online resources, there are textbooks and other professors who will tell you to make QV, flip V if Q is negative. That's more thinking, that's more work. Don't do that. More mistakes. Any questions about what I just said? No. Turn to your neighbor and discuss. What did Tucker just say and why did he say it? What happens if Q is negative? Then I want a question. If what's negative, what goes the other? The direction of what? What's that? Force, yeah. Negative charges feel pushed the opposite way.
This one, it's like the first course is this.
First
Second
vector.
one is-
Oh, there's 6 permutations you could do of this. 1, 2, 3, 1, 2, 3, 1, 2, 3.
So if it is up into right,
I would do that up, right.
can I get it?
We'll call that in.
Right, then.
Yeah. Wait, hold on. That's to your left. You just pointed your finger left. Yeah. Good. Any internally consistent way of doing it? Yeah. Okay, bring it back together. Ask me a question. Yeah. I suggest you don't think about this doing something to this. Calculate this. You know what V cross B is. Force flips. Negative up is down. This doesn't make this negative up, doesn't make this not up. V cross B is still up. If V cross B is up, a negative multiplication doesn't change V cross B. V cross B is just up. If this were 3, this were 5, and this were -1, 3 times 5 is still 15. The answer would be negative 15, negative 1 times 15, but that doesn't mean you change 3 times 5. It's just the final answer includes all the parts. Yeah? Last chance for questions about this. This will be at least one question on the midterm. I haven't written it yet. I'm going to write it on Thursday. But this will be, I swear to you, this will be at least one. Okay, I've got numbers and then I've got centripetal. Let me ask, hold on, let me get a quick survey. Google question H for those of you who can. Juju question H. Give me a scale of how you're doing with this magnetism crap. 1, I'm more confused about magnetism than when I walked in the room. 5, I am so bored, move on. I've got this completely. Give me a scale 1 to 5. 5 is you're perfectly comfortable. 1 is you're exactly lost. Please constrain your answers from 1 to 5. I've got people answering outside that range. 6, 7, hilarious, but no. Even better than the first class. Stop, go away, go away. Okay, uno thing more. I wish to emphasize something that we spent a significant amount of time on, but also my lab section suggests that has not sunk in. To find the direction and magnitude of the magnetic force, there are 3 steps. And step 1 people are missing. I'll tell you Q, V, and B and their directions. And a lot of people are just, oh, I've got numbers I can multiply. Step uno. If the directions for velocity and magnetic field that I give you are the same, force is 0. Don't get so excited about I've got numbers, I can multiply them. I mean, good job, you can multiply, but that's not how you get the answer for magnetic force. If the directions, I should say, of velocity and magnetic field are crossed, if they are perpendicular at right angles, 90 degrees, then you multiply. That's the amount of field, and then the direction right-hand rule it. So you got to think. Don't just multiply because there are numbers. If the directions are in the same line, the answer is 0. Oh, come on. F for real fast. Chop chop. I need to tell you the charge on a proton, maybe. Are we on H? No, H was the survey. I for I. What? What's what? What did he what? What waters? Charge on a proton, 1.6 10 to the negative 19 in the SI unit. Okay, ready, set, go. Chop, chop, quick like a bunny. Question text. Proton moves at 10 to the 7 meters per second in the direction of a 0.5 Tesla magnetic field. I give you charge is 1.6 10 to the negative 19. What do you do? What you gonna do when they come for you? Oh my God, people are getting it. People get it. I just love you guys so much. Great. Just about everyone is able to see that if you're moving along a field line in the direction of the field, parallel to the field, straight along field, 0. Good job. What if I said crossing at 90 degrees? Then multiply. Okay. Y'all are so squirrely right now. If a charged particle freely moves in a magnetic field, it circles. Doesn't go faster, doesn't go slower. Magnetic field's basic effect is to turn charges. You are turning, not speeding up, not slowing down. You end up in circular path. Can deduce that later. Okay, so the radius, not resistance, the radius of that path, muy importante, the radius of curvature of that path, if you form a circle, look at the radius of the circle, is given by the expression mv over qb. Whatever's mass of the thing that's orbiting, whatever that thing's velocity is, whatever that thing's charge is, and whatever the magnetic field is. This will be a question on the test. And it will be as profound as can you multiply and divide numbers? Do you recognize when the instructor says this will be on the test, do you recognize this is something you should do? Yeah. Okay. So stick around because I'm going to give more on this. But the 100-mile view is charged particles and magnetic fields don't get faster or slower, they turn. This is how big the circle is, the radius of the circle. Plug in numbers about the particle, its mass, velocity, and charge. Plug in the number for the field, you'll get how big the circle is. That's it.
Mass of the charge. Like
Mass of the object feeling the field, yeah. Mass of whatever's moving. Yeah. Anybody else want me to revisit what the terms mean?
but it's not a proper circular motion, right?
Yeah, it is.
It is.
Can be a helix, but from the looking along a field line, you've got a circle. If that's the only force you got. You add in other forces, electric field, gravity, magnetic force. I'll talk about that more, but, and this is a big but, and I cannot lie. I suspect that it will benefit people to go study more than for me to make the connection with last semester. There is a connection which will highly benefit if you are an MCAT student. There's a connection which will, if you are inquisitive and wish to see how this connects with mechanics, where does this formula come from? For the students who aren't MCAT or harsh, wait, that's the same. For the students who aren't MCAT or who wish to see this, if you're mentally tired, get out of here, you're excused early. If you're MCAT, stick around. Or if you just want to see it. I'm going to derive this formula and a related one, but you may leave, especially, we are done like Dunning-Kruger. If you are MCAT, you'll want to stick around, probably. But this is everything you need to pass the test. I'd go fast because I do want the MCAT students to see one more thing. They will use this. Yes, exactly. Wait, how'd you know that?
My brain says. Keep walking, buddy. Keep walking. Big teaching.
That would help.
MCAT student, would any of this benefit us for this class, like the test?
You now know everything necessary to get a 100% on the test.
Okay, perfect.
Okay, go fast, go fast. Go fast, get out of here. I love you, but go. Okay, anyone left in here is going to be required to stay. You have to stay if you're still in here in 5, 4. If you're gonna get out, go fast. All right, that's enough. Okay. So my MCAT estudiantes, you need to know stuff about last semester. And in particular, there is everybody's favorite topic from last semester, the easy peasiest topic from last semester that I think it would be worthwhile to review. This does pop up. Circular motion. I mean, what did I just say? A particle moving, charged particle moving in a magnetic field tends to make a circle. If it's free to move in any way it wants. If it's constrained to move in a circuit, well, it'll move along those wires. I'm talking about free, in vacuum, air, whatever. So. You need to remember some things about circular motion, and that's what I'm going to drag you through now. We're going to see where this formula, that formula, mv over qb, comes from, and in doing so, connect stuff. What have we learned? What have we just learned about magnetism? What does QVB tell us? The force. The force. We know something about force. Let's write down an equation about force. Force equals, I'm going to assume that everything's at right angles. If it's not at right angles, then you don't get that anyway. So let's just pretend we're starting. So I'm not going to have to think about the direction. F equals what? Always? Mass times acceleration. Sure, why not? F equals ma. I mean, as I was saying, if a free particle moves in this direction, then the only force on it is QVB. Acceleration. Circles. What's the connection? You remember? If you're moving in a circle, do you go faster and faster? Not necessarily. Do you go slower and slower? Not necessarily. Are you accelerating? Always. Always was the exam answer. Why? Acceleration is any change in your velocity. Velocity is not speed. Velocity is speed and direction. Circles changing direction. Circles accelerating. Always, 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 always. Anyone, for 1,000,000 bonus points, anyone but Sahu, remember the formula for the acceleration of circular motion. Oh my goodness, she remembers. Good job. Solve for R. Everyone solve for R. R. Jazzy. V divides. Let's kill the fraction. Get R alone. Yeah? You see? Did you do that algebra? Did you divide V out? Yeah, good. You see? Now, there's one more thing. Here's the circular motion connection. Who's used, heard of, learned about, friends with a mass spectrometer? Mass spectrometry. Really? It's a hugely important device in chemistry. Wait, which class did you learn about mass spec in? In high school. Okay. What class did you learn about it in? In which class? Who's done OChem? Who remembers going down into the basement and using something called a mass spectrometer? Okay, this is why anybody cares about this formula anymore. There are other things you could do with this, but screw that. This is the core of one of the fundamentally most important tools that many of you, and if you were doing what does the sample contain, whatever, identifying components. This allows us to measure how much of what molecule is present in a substance, and here's how. I'm going to build you a mass spectrometer. It's all this formula, baby. I'll build you a mass spectrometer if I can zoom in. Come on, punk. Oh, for God's sake. Scroll over here. Okay, here's how you build a mass spec. Powderize a sample, break it up, bang, 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 bang. Got individual little tiny, tiny, tiny molecules of sample. Heat them, heat the heck out of them, get them really hot, and electrify them. Ionize them. Take an electron off of each molecule in your sample, okay? Right? Standard chemistry BS. Everyone can imagine ionizing a sample. If you take an electric field, we'll learn more about those later. Basically, if you take electricity and attract with the electrical force those ions, you can get them moving, some faster, some slower, in a given direction. You attract it to an electrode, and that electrode is not solid. It's got holes in it so the ions can fly through. Yeah? Following so far? So mass spec, all the pieces, all the molecules that made up the material are flying through the air. There is a device called a velocity selector, which is trivial to build, which is electricity and magnetism, but which I'm going to ignore for right now. I may revisit it when we talk about electric field. It's not hard, but I don't know. I'm going to talk about 5 things at once. And the point of a velocity selector is you can control the velocity of the particles that get through it. So now only particles with a given velocity are going through this velocity selector. The velocity selector is a long tube, and you enter the mass spec chamber for real. Are you following? Can you visualize all of what I'm saying? You get a bunch of ions of the molecules of the material moving at a known knowable speed. You put this area in a big magnetic field. Okay. You control that. You make the magnetic field. It's your magnetic field. Well, not yours, but the designer of the device. Here's a known magnetic field B. These particles, what are they going to do? They are moving. They are charged. What is their motion going to be like? Where is the center of the circle going to be? When does it start curving? Does it go into the chamber and then start curving? I think it starts turning the instant it enters the chamber. You have a charged particle. He's going to turn immediately. And then smack into the wall where you put a photographic film, or nowadays a computerized detector. A particle with bigger radius starts turning immediately and smacks in over here. Particle with a medium radius smacks in over here. All right, well, we've got a formula. Radius of curvature equals mv over qb. Solve for m. Mass equals, take a look at what these terms mean and reflect on how you can get them. What's charge? You ionize something. 1 electron worth, right? And when you ionize something, the most common thing to do is you strip off 1 electron. What's B? You control that. What's V? You control that, the velocity selector tool. If you observe R, you can easily calculate mass. This is a way to weigh molecules that you could do even in outer space. There's no handy spring scale able to pull things together. Yeah. In the practical chemistry, OChem, whatever real world of labs, this is a vital tool for identifying, because let me point out, not only do we identify what the masses of the molecules are, you can look and see, did this point get a lot of hits? Is this dark point on the very dark point on the photographic film? Is this photo sensor, this camera cell here, LCD, LED, whatever, cell detecting a lot of particles? Then there's a lot of molecule X. This radius is bigger, a heavier molecule lands out over here. I guess there's this much of material Y. You can get a graph, a spectrum of how much of what material. Oh my God, that's exactly the composition of your material. Mass spec, super powerful tool. My 3 o'clock class, half of them have heard of it. Does this, has this triggered any bells? Yeah, I'll read it up. Google this, Google this. Maybe looking at it will trigger something. Mass spectrometer. And I mean, I hear a lot of people just shorten it to mass spec. Field is mass spectrometry. Okay, so, what's the physics? It's right there. It's right there. This formula is the core. Without this, we would not know, all right, some particles go here, some particles go there, some particles go, positive charges would go there, negative charges would go there. We wouldn't be able to know jack, we wouldn't be able to do anything with this. But by knowing that the curvature of the particle is directly related to its mass and known, knowable quantities, bam, you can measure how much of what is present in a material. The amazing tool. Before this was invented, I mean, seriously, how else could you possibly know the molecular makeup of something down to every molecule? There's no chemistry tool that you could do other than this that I can think of. Okay. You have seen a smidge of circular motion. Hopefully, that has triggered some memories. Hopefully, some of those memories are not PTSD flashbacks. And we talked briefly about mass spec and how this equation is actually important for something. Any questions before I dismiss everybody? Yeah, Harsh.
What is the name of this device?
George. I don't know. Tesla coil.
Yeah,
I've seen
so-
this.
So is it the same concept where the particles are moving this way?
We'll talk about that in a second. If I've got mass times square of velocity here, charge times single velocity here, if I divide by v on both sides, what's v squared? It's v times v. V dies. There's only one v left. I mean, v squared over v is v. I love each and every one of you because you are all the best. I'll see you on Monday.